Welcome to Investigation 2.1, Looking for Squares. This is the launch video for this investigation. It will be posted up on YouTube and on our class file, and in our class file cabinet, and hopefully you'll be able to use this to work through the 2.1 investigation. In this investigation, our focus question is how many different squares are possible using dots on a dot grid as vertices? Why are some square areas not possible? So please add to your table of contents this information here, 2.1, looking for squares, and then add to your actual missing page the focus question. Our sub will pause the video so you can get that written down. Now on to this. We have our focus question, that how many different squares are possible using the dots in a dot grid as vertices? Why are some square areas not possible? So please add, now I would like you to flip to your words worth knowing and add the word vertices. Vertices is a concept we need to understand, so I'm going to identify vertices on various shapes, and hopefully a little light bulb is struck in all of you. So looking at this, essentially a vertice is you guessed it, hopefully you guys are shouting it out in the classroom as I fumble around with this, it is a corner. It is a corner of a shape. So make sure you get that into your words worth knowing. It's very important. If you want to, draw yourself a picture or two. After you've done that, if need be, we can pause this video. And after that, we will continue on with the investigation. So let's move on. So we know that vertices are important, and it looks like we're also going to be using dot grids to find square areas. So let's do just that. So let's talk about some of the areas that we were looking at in 1.3. So here's the question. Which area is easier to find? What strategies did you use? What shapes were helpful when looking at more complex shapes? So looking at these two, we have, I believe, this one in red was number 4. That was shape number 4. And this one in purple was shape number 8. And the question first that we need to ask ourselves is which one was easier to find, which area was easier to find. Hopefully your answer is that shape number 4 was easier to find because we could break it up into squares and rectangles and triangles. So we were able to see that there was 1 square unit here, there was 2 square units here, and then we had 2 half units hanging off, and so we would end up with 4 units squared for that red, or for that area of that red shape. For this purple shape, however, things got a little bit more complicated. And if we looked at this, if we were to look at this, this is the only sort of block of 2 units that we can definitely say that we have. It also looks like we have a half a unit here, and then everything else is a little funky. So I'm just going to split this up into triangles, and then we can deal with it from there. So we have a triangle right here. It has a base of 1, 2, and a height of 1. So that means it's 2 times 1 times a half, because that is our equation for a triangle. Base times height times a half, or divided by 2. And we would get 1 unit squared out of that. We have another one that is 2 units high and 1 unit across, so that's just the opposite. So we have a base of 1, height of 2, and we're multiplying it by a half or dividing by 2, either one. And we also get 1 square unit. Then we have this other triangle along the bottom. If we were to look at this triangle and sort of flip it on its head, we could say that this is the base. I know it's upside down. That is the base. It has 2 units across, and then we have a height, so the tallest point down to the base, perpendicular, and that is 2 units up. So we have 2 times 2 times a half for that baby. And we end up with 2 units squared. So if we were to add all of this up, we have 2 units plus 2 units plus 1 unit plus 1 unit, so that's a total of 6. And then we have one last half, so we have 6.5 units squared. That shape was a little bit more complicated. Now, what strategies did we use, or what strategies did I just use? I just used the whole concept of breaking things up into squares. I'm going to type this in: squares, rectangles, and triangles. Oops, triangles. I'll add that in here. So I created squares, rectangles, and triangles. And then what shapes were helpful when looking at the more complex shapes? Obviously the squares, rectangles, and triangles were the most helpful, because we knew that triangles, depending on their size, could potentially be half the size of a square, and rectangles are easy because it's just base times height to find the area, and so on. So let's go on and take this concept a step further. Now, in problem 1 or 2.1, we're going to be drawing our own squares and we're going to find their areas. So you're going to be given paper, or if you look on your table, there is paper in laminated sheets that looks like this, and we have 5 by 5 dot grids. To start out with, I'm going to draw a couple of squares. So here is one square, and I'm going to label this 1. Mainly because it has a base of 1 and a height of 1. So 1 times 1 equals 1 unit square. So this is a square that is a 1 square unit square. Kind of cool. Let's see, here's another square that I could potentially draw. I'm going to draw a couple of the most obvious ones. Here's another square that I could potentially draw. And remember, this is 5 by 5 dot grid paper. So in other words, we have 5 dots along the bottom of that grid paper and 5 dots up. And no squares that we're going to make are going to be bigger than 5 by 5 when it comes to the dots. So here's another square. We have a square with 5 dots along the bottom, and we have 5 dots that are covered along the sides. So 5 by 5 equals 25 units squared. So there's 2 different squares that we could create. I'm going to label this second one 25. This one is 1, and I'm labeling them by area. So let's take this concept a step further. What is the largest square area we can draw using the dots as vertices? And make sure you're using square area. So I want you to be drawing squares. Not rectangles, not triangles, squares. And I want you to figure out, if the dots were vertices, how big could we get? So we're not doing anything inside of these dots. That's not happening. That's not our goal. Instead, we are doing things on the dots. So the points of each, or the corners of each square, need to be aligning with the dot. And what is the smallest? So I want you to think about that. Hopefully you are having an epiphany and saying, well, it's what I have already drawn, and that would be awesome. But I also want you to think, do you think you can find a square area for every number between 1 and 25? That is your launch into problem 2.1a. So for 2.1a, you are literally going to be drawing as many different square areas that you possibly can. So we have the little 1 by 1 square, and we have a 5 by 5 square. But my question of you is to make sure you get all of the square areas in between that you potentially could. So, can you get a 3 square area? Can you get a 2 square area? Can you get a 17 square area? Figure out all of those. As well, I want you to think outside of the box. So don't just think things can be horizontal and vertical. Consider squares that could be a little off kilter. So enjoy question 2.1. Your job is to do investigation 2.1, A and B. And I'm going to add a little bit here. So please, in your mission, complete the reordering of your squares in that. So essentially, you are going to do work on the dot paper that's provided in the middle of your table, but question B asks you to organize your set of squares by size and then describe the side lengths you found. So whatever squares that you created, make sure you don't double up on the same size square. I would like you to then reorganize the squares in your actual mission with your own personal grid paper. So you're going to copy down your work. Enjoy. When you are finished, you may work on the homework for Investigation 2.1. It is on the board, so check that out, and I hope you have a good time. Bye! I just realized I forgot something. So first of all, that doesn't need to be there. So please reorder the squares in your mission. But know that after you are finished, if you would like, you can check my mission, so my teacher mission, to see if you've gotten them all. To check your work. Totally fine with me. Enjoy. Bye.